Bitcoin Core developer proposes new type of pruned node. Bitcoin Core developer James O'Byrne has proposed a new way to run a Bitcoin pruned node. His proposal overhauls the conventional method for pruning Bitcoin's blockchain. Pruning, of course, has been available to Bitcoin node operators for years. A full node is a computer or a custom machine that validates proposed Bitcoin transactions against consensus violations, like double spending or increasing the quantity of coins above Bitcoin's 21 million hard cap. Full nodes validate transactions against Bitcoin's rule set, plus an unabridged copy of Bitcoin's ledger of transactions. Bitcoin's full blockchain is currently over 464 gigabytes in size, so most full nodes install a hard drive with storage exceeding 1 terabyte. A pruned node drastically reduces the amount of hard drive space required to validate incoming transactions. Pruning eliminates the need to download and store old transactions with a sufficiently high number of confirmations. For example, a pruned node operator might consider any transactions that have been validated for 100 successive blocks as immutable, allowing their computer to compress all data prior to 100 blocks ago into a single cryptographic hash. With standard Bitcoin Core software, node operators enable pruning by setting a maximum number of megabytes they are willing to store in their bitcoin.conf file. They can also modify this setting in the settings area of Bitcoin Core's graphical user interface, GUI. The two largest software clients for Bitcoin nodes, Bitcoin Core and Bitcoin Qt, can be pruned. However, once the node owner has activated pruning, they may not transmit old blocks over the Bitcoin network nor verify old wallets. Of course, pruning has trade-offs. First, however, to O'Byrne's proposal. James O'Byrne proposes a new way to run a Bitcoin pruned node. O'Byrne has proposed an update to the method by which full nodes prune. This proposal is part of the larger Assume UTXO protocol project. Rather than the status quo, setting a number of blocks and compressing historical blocks prior to that milestone, O'Byrne's Assume UTXO is an experimental way for new Bitcoin full nodes to delay their need to verify historical transactions until the user receives recent transactions. Assume UTXO compatible node clients would contain a hard-coded hash of the conditions necessary to spend all Bitcoin, the UTXO set, as of a safe, recent point in time. O'Byrne's variant of the popular Bitcoin Core client, Bitcoin Core 25740, supports Assume UTXO. Because of its importance, developers would have to check any revision of the hard-coded Assume UTXO hash for correctness during code review. As long as the snapshot hash is correct, it would allow pruned node operators to opt in to disregarding full data prior to that hash. This trimmed blockchain file would be much smaller than Bitcoin's entire half-terabyte blockchain. In addition, O'Byrne's proposed update could add background validation to the Assume UTXO protocol. The Assume UTXO proposal adds serialized UTXO sets, reducing the time needed to sync a new Bitcoin node. It also reduces the storage space required to save the Bitcoin blockchain. Recap of the Assume UTXO pruned node proposal. In summary, James O'Byrne proposes that pruned node operators may optionally trust a developer-reviewed snapshot of the blockchain at a specific point in history. A pruned node can use that snapshot hash to reduce the large file size of Bitcoin's blockchain. Once the node has passed an accuracy check of Bitcoin's ledger using that hash, the node can delete the information used to perform the check the next time the software client restarts. After abridging this data, the node has become a pruned node. Like other pruning techniques, O'Byrne's proposed feature reduces blockchain storage requirements. Developers are still working on finalizing the Assume UTXO proposal. To be clear, Assume UTXO is not in consensus with the main Bitcoin network today. Development, safety checks, and code review are ongoing. Bitcoin Core developers are discussing O'Byrne's proposal, debating its pros and cons, and debugging drafts of code. For more informed news, follow us on Twitter, Instagram, and Google News, or subscribe to our YouTube channel.